Welcome to SQL with Python. In this video, our focus turns to optimizing SQL queries, having considered SQL transactions and Python in the previous video. This actually is part of those advanced SQL skills we need to learn. So, turning to the introduction, we see that efficient SQL query design is essential for building fast, responsive, and scalable data applications. Even in coding, right, it gets to a point where you need to optimize, you need to make the code faster, or you need to write your code in fewer lines to still do the same job or even a better job, right? And that's where optimization comes in. So we can optimize SQL queries. So this comprehensive guide introduces indexing, query tuning strategies, and demonstrates how to use Python's built-in SQL3 module to analyze and optimize SQL query performance on SQLite databases. Of course, all these things I'm doing, we can also do using MySQL or even ProgressQL, but I'm using SQLite, and with little bit of tweaking, you can actually do the same for these other databases in SQL. All right. So the first question is to understand. I think I need to emphasize here uh the idea of indexing. Say you have indexing. Let me do it this way. This, then this, and then we come here, query tuning. Query tuning is another important thing to highlight. Okay. Yeah, so we have those. So first thing, understanding indexing in SQL. Now, you know the idea of a book, right? When you have a very big book, like a 300 page book. So sometimes if you need to find an information quickly, you go to the back. The back is called the index, and then you can find the word you're looking for, and the page you can find the word, and then you just go straight to trace that. That's the kind of idea indexing represents also in SQL or SQL. So what is an index? It is a data structure that improves the speed. It improves the speed of data retrieval operations at the cost of additional storage and slower writes, right? So you want to retrieve information faster, you go for indexing. You can think of it like an index in a book, which helps you to locate information quickly, just like I just described. So let's talk about types of indexes in SQLite. Well, I mean, that should actually be like types of indices, but I think this is how it is written when it comes to SQL. So SQLite provides several types of indexes. We have the single column index, right? Where you can create, so you use this kind of syntax. So this is not implementable, it is in raw form. So we just see it as an example. So create index, then you call it this name, idx underscore column underscore name on the table name, the table on which you're creating the index, and the column name on which you're creating it. That is a single column index, what just one table. Then you have a multi-column composite index. So I mean just one index, right? So here you create index IDX multi, that's to indicate multiple column. It doesn't have to be exactly that, it can be anything else. On table name, so you have your table name, then the columns on which you are going to have the multiple column or composite index, column one, column two, indicate them like this. And you also have unique index to enforce column uniqueness. So if you want to enforce column uniqueness, you can have an index to take care of that. So you can create unique index called idx underscore unique underscore co on table name, whatever the table name is, and then the column name like that. So the question now is, when do you use indexes? Once you use indexes, you use indexes for columns. For columns used in where, order by, join, and group by clauses. I mean, we've used these kinds of things previously. So any columns where you use this kind, on which you use this kind of things, um, you can actually use indexes. So when the column has high selectivity, maybe it has many distinct values, so you can use indexes to make things faster. Now let's set up an example and see how this works. So here we want to set up a SQLite database with a sample table and test query optimizations. Okay, so let's see how this goes. First of all, you want to connect to your database, you want to create a table. I mean, you want to create the database, or you want to connect to or create the database, right? And then you want to create, so the database here is sales database, and then we want to create a table called sales inside the same in the same database. That's possible. And then the table will have ID, customer name, product amount, and sale date, right? Then from there you can also populate the table with random data. This is the first time we are doing this random data. So you do it only once, and then you know uh so see what happens here. This is the first time this is happening. So we define a Python function here where we have the name of the function is populate underscore data. N is 200, so you are populating with 200 random information using whatever you supply here, for instance. So start date is date time, that's 1st of January 2020. For in range N, the N you have supplied there. So for in range 200, name, so for the name now, it means you're going to have Alice, Bob, Charlie, Diana as many times as possible. And then you have the product, random choice of products. You have book, pen, notebook, bag. So it means you can have any of these names with any of these choices. Then the amount is also random, and you're going to round it to two decimal places. So it can be 50 between, like I think it's like between 5 and 100, like that. So the amount just keeps going. Then you can have your date to start date plus time delta. So you also have that one randomized also. And then now it's time to execute. I think I need to uh put the line numbers for easy reference in exactly this way. So now in line 30 now you want to execute a SQL statement. So insert into sales, customer name, product amount, sales date values, and then you put this this names this name keeps evaporating each time. That should be something standing for something. Now I've forgotten again. Okay, then you now put all the name, product amount, dates, and all that. And then you commit is to save, right? Then you can use this to now run the function, right? Right. So I can run this now and no error, so it's done. Okay. Now, um, we go on to talk about query performance measurement. Now, you can measure the performance of your query in SQL, right? In a bit to make things better. So you can use Python's time module to measure execution time of queries. So everybody wants just like when you write code, you want your code to run faster, you know. So as a result of that, optimization becomes necessary. So the first thing is you want to query without an index. If you query it without an index, see what happens. We just learned about indexing. So if you query without an index, imagine you query, you just select everything. Star means everything from sales, where the time sales date is somewhere in 2023. Then for Python, right, you just say start time is equal to time dot time. All right. I think we had imported the date time thing because we need it. So from date time, import date time, time delta. And okay, in fact, we have imported time too. So that's where we are getting this from. So if you want to measure time, so you start time is time dot time. Then you have cursor and you execute this query here. Then you get the rows where you're fetching all. Then you print rows fetched, the number of rows fetched you indicate. Then time taken without index. So you have time dot time, that's the beginning time minus start time. Okay, the whole thing takes minus the start time, um, so in to four decimal places or something in seconds. So that goes, and then if you run this now, yeah, if you run this now, see what you get. So it's fetched 54 rows, and then the time taken is 0.001 seconds. That is the time that actually takes, right? So you have time dot time minus start time, and it gives you this in seconds. So this query is slow because STRF time on sale data disables index use. So because of this STRF time, no index is used. So take note of the time 0.001 seconds. Now, what if you now optimize that same query and by using index? So you create an index, and how does that happen? So you say cursor to execute, and this red thing now is the SQL query. So create index if not exist. So and the name of the index is idx underscore sale underscore date on the sales uh, table. Uh, with this sale underscore date, right? So you are creating the index on the sale date that we have as part of the table, right? And then with this, you commit. So control enter and that's committed. The next thing is you want to write an index friendly query. Now you have created an index in step one up here. So how do you now create an index friendly query? So the optimized query now becomes select all from sales, where sale date now is greater than or equal to 1st of January 2023, and sale date is less than 1st of January 2024. So instead of just writing what we had there now, so now we have created an index on the sale date column, and then now we want to measure the same thing we did up here, you know, that we did on query. You now want to do the same thing on the optimized query. Mind you, the time that was spent up there is 0.001 seconds. Let's see if this makes it better. Can you see? So the time up there was 0.001 because we did it in 4 decimal places. So maybe I should take it to like six decimal places. That is 0.001002. So if we come back here and run it, maybe we can see now this is 0.001, which is a bit, at least a bit smaller than what we had up there, right? So this helps you to save your time, to save time, no matter how minute that is. Okay, so we see that indexing actually gets to work. So if you are dealing with a very big database, you can appreciate the timing thing better. So we can also analyze query execution with explain. So you can inspect how SQLite executes a query using, I think I did I skip something here? Oh yeah, I think I talked about it. Okay. So you can inspect how SQLite executes a query using the explain query statement. So now you have cursor to execute. So and you have if an F string where you now say explain query, then with the optimized query now you can now, so the optimized query you had used up here, all right. So explain query actually helps you to inspect how the SQL Lite executes the query, and then the plan. If it's cursor, you fetch all the print the query plan, right? So print query plan. So for P in the plan you have here, then print each one after the other. So this indicates the SQLite used index. Okay, let's run it. So because we got this now, so query plan 3,0,0, and that's search sales using index IDX sale date. Now you see, this is the index we created before. I just sale dates and sale dates like that. Sale dates greater than ah, I keep forgetting this English word for something to represent something. Not default. I keep forgetting. Okay, and sale date less than this also. So the fact that this worked this way means that this indicates that SQL has used the index you created the other time, because we just created the index around here. All right, and then we have it used. It's showing that it has used the index here. So we move to 9.7 where we talk about additional optimization strategies. So now, one way to optimize your SQL query is to avoid select star. Select star means you're selecting everything. So in this case, so what you do otherwise is use only necessary columns. So instead of saying select all the columns, just select the specific thing you need. Maybe you want to select customer name amount from sales where blah blah blah. You can do that. Then another thing is that you can limit result set. Okay, so you can say especially this is especially useful for dashboards or previews. So here you can select all from sales, and then you order by sale date, descending limit 100. So you want from descending order, right? You limit it to 100. Okay, so let's see an example here. You can use prepared statement too in Python. So imagine you have a statement called stmt. So select all rows from sales where customer name is this is default. Is it default? I forgot it. So this question mark is something standing for what you're supposed to put there. So for standing for customer names, an amount greater than question mark, standing for a specific amount you might want to put in later on. So and here we now have the parameter. So Alice is the customer name here, and 50 is the amount. So we want where customer name is Alice and amount is greater than 50. Then we have cursor to execute. So you now put the statement and the parameters here. So this is you using prepared statement. So you make the statement and you put the parameter. So you put the two together, and then you can get the results where you fetch all, and the results can now come in this table format. So since what we did was randomized, right? So you have 2404. So the same Alice buying different things, with different cost and different dates like that based on what we just did now. So you can use prepare statements in Python. So prepare statements enhance performance for repeated queries and mitigate SQL injection risks. In fact, it is because of the injection thing that we also use this question marks, which are placeholders. That's what I was looking for. So the question, whenever you see question marks in SQL, they are placeholders to take in whatever you now give it later. All right. So you need a customer name Alice and any amount greater than 50. So you can see you have all these amounts here now. They are greater than 50. So you see all of them are greater than 50 based on the something, based on what you have chosen. And because the thing is supposed to be random, Alice is fixed, but whatever Alice is buying and the amount is always they are different because they are randomized, right? So we can also use you can use transactions for batch inserts. So maybe you want to insert new information into your database. You can use transactions for batch insert. So you can count rows before insertion. For instance, you say cursor to execute, select count all rows from sales, right? And before count, you want to see cursor to fetch one. So whatever you have before count, you get it by line 3. Then now you want to insert 1,000 rows inside the transaction. Okay, you want to insert 1,000 rows inside the transaction. So you just say with connect for underscore in range 1,000. So because we want 1,000 rows, so cursor to execute the SQL statement. So you have insert into sales table, customer name, product amount, sales date values. You have all the placeholders, and then you want to have test book 12.99 2025 00 1st of January, right? And then you now count rows. So you're counting rows before, you're counting rows after. So you have cursor to execute, select count rows from sales after all that has been done. So after count will now be cursor.fetch one, and then you get that. So the output results will now be rows before insertion, before count, rows after insertion, after count. Then rows inserted, it gives you the difference in rows inserted. Okay, so you see rows before insertion was 200. You remember when we created the table in the first place, we put 200, right? We had 200 rows here. So now before the insertion, we had 200 rows. So you need this to check if what you have done is okay, right? That's why this is necessary. Before insertion, we had 200 rows. We now inserted one, but after insertion, we have 1,200. So the difference between the two is 1,000, and that was the intention to insert 1,000 rows inside the transaction, right? So in 9.8, we can visualize query performance in Python. So you can collect and plot query times to track performance over time. So here, because we want to see a plot, so you need to import matplotlib.pyplot as PLT. I mean, we did this under data analysis with Python, where we talked about data visualization. So here you see the times, and then for underscore in range 30, start is time.time, cursor execute the optimized query where we have used index, then cursor fetch all, times append, time to time minus start, and then you can plot all this now. So you want to plot the times like that. So the title is query time over iterations. X label is iteration, while Y label is time in seconds, and then you can show the plot. So I run that now, see what happens here. Okay, so you have the time thing going on like that. Okay, and the peak is about 0.01, just like what we saw before, because we had saved the time, because the data is random. So if I run it again, you see the plot changes. If I run it again, the plot keeps changing because we are working with randomized data sets, right? Okay, so in summary, we have best practices checklist to help us optimize SQL or SQL queries. So in practice, index selective where columns. So that will help with faster row filtering. You can avoid functions on index fields, and that ensures index usage. Avoid select star, which reduces data transferred. You can use limit, which speeds up queries with large results. You use transactions for batch writes, which increases insert performance. You can analyze with explain query plan, which helps to understand execution flow. You can use parameterized queries, and this improves reusability and security. Okay, so in fact, the final notes now. SQLite is an embedded database. So while these tips are essential for SQLite, they apply broadly to my SQL, PostgreSQL, well, my SQL, PostgreSQL, and SQL Server with some engine-specific differences. So all these things we've done using SQLite, you can actually do using other SQL databases, right? So Python via SQLite provides a lightweight and flexible way to simulate real-world performance using real-world performance tuning task for educational prototype or local application. So with this, we come to the end of this video. I hope you have learned one or two things. Let me know how this has been helpful for you. And if there's something you'd like me to do, as far as SQL is concerned, I might be able to try it out. Yeah, if you have subscribed to the channel, you are learning a lot already. If you have not subscribed, please go ahead and do that right now and hit the notification bell so you can always get alerted each time a new video is released. Please, of course, now I have membership on this channel. So if you want some extra privileges, some special privileges, you can become a member. There are 3 plans currently. It may become 4 very soon, but now we have 3, so you can just click join the channel and see the options you have and the benefits attached to it. So but of course, if you do not become a member, you're fine. As a subscriber, you still have access to the videos. All right, so some of these videos, so the videos that are meant for everybody for sure. Okay, so be sure to also like and share so that more people can have access to the great content I have going on here. In the next video, I'll be talking about yeah, using pandas with SQL, like doing so, bringing data from your database and then doing data manipulation, data analysis with it using pandas. So that's like in a sweet marriage between SQL and pandas. Till I come your way again, keep doing maths right. Bye.